the living legacy of Chernobyl. Science, war, and the long shadow of radiation 40 years after the catastrophic explosion of Reactor 4, the Chernobyl exclusion zone is no longer just a monument to a nuclear disaster. It has become a complex intersection of scientific research, ecological rebirth, and the brutal realities of modern warfare. While the world often views Chernobyl as a desolate, abandoned wasteland, the reality on the ground is far more nuanced. It is a place where scientists fight to understand radiation, where wildlife thrives in the absence of humans, and where the scars of the 2022 Russian invasion have added a new, violent layer to an already tragic history. The physics of danger. What remains? The immediate, acute danger of the 1986 disaster has largely passed, but the radiological threat is far from gone. The contamination released during the explosion consisted of over 100 different radioactive materials, each with different lifespans. Short-term threats. Iodine-131, which primarily affects the thyroid, has a half-life of about a week and has long since decayed. Medium-term threats. Cesium-137 and strontium-90 have half-lives of approximately 30 years. Their levels are gradually decreasing, but remain a factor in environmental monitoring. Long-term legacies. The most significant danger lies in the concentrated materials within Reactor 4, such as uranium-235 and plutonium-239. With half-lives spanning thousands to millions of years, these materials ensure that the site will require specialized management for millennia. The completion of the new Safe Confinement, NSC, in 2016, a massive 1.5 billion euros arch designed to encase the ruined reactor, was a milestone for global safety. It provides a stable environment for the long-term process of decommissioning, a task expected to last a century. A scientific sanctuary interrupted by war for decades, Chernobyl served as a premier global laboratory. Scientists studied how radiation affects biology, how bacteria might eat radioactive waste, and how ecosystems recover in human-free zones. However, the Russian invasion of Ukraine in 2022 fundamentally disrupted this work. During the occupation, the zone became a frontline. Russian troops used the area as a corridor toward Kiev, leading to vandalism of research facilities. Laboratories were looted, computers stolen, and years of irreplaceable data and biological experiments destroyed. Militarization of the landscape. The once quiet exclusion zone is now heavily fortified, filled with military checkpoints, and most dangerously strewn with landmines. Threats to wildlife. While wolves, moose, and lynx have flourished in the absence of human activity, the presence of mines poses a lethal threat to both animals and the researchers attempting to monitor them. The human element. Myths versus reality. There is a common misconception that Chernobyl has been a ghost town since 1986. In reality, the reactors continued to operate until as late as 2000, and a small community of self-settlers has persisted. Today, roughly 40 civilians live in the city of Chernobyl, and several others reside in nearby villages. These residents, like 88-year-old Yevhen Markovich, have built lives amidst the ruins. While experts note that much of the zone is technically safe for habitation with, some residents receiving less radiation than those flying in airplanes. The psychological and social impact of the disaster remains profound. The broader impact. A global lesson: the legacy of Chernobyl extends far beyond the borders of Ukraine. One of its most significant, yet often overlooked, impacts has been on the global energy landscape. The disaster significantly soured public opinion on nuclear power, potentially delaying the transition to carbon-free energy and contributing to increased fossil fuel reliance and subsequent air pollution. By continuing to study the zone, Ukrainian scientists aim to bridge the gap between public fear and scientific reality. Their work provides critical insights for managing future nuclear incidents, such as the aftermath of the Fukushima disaster, helping the world navigate the delicate balance between technological advancement and environmental safety. Conclusion: Chernobyl remains a site of profound contradiction, a place of deadly radioactive remnants and thriving nature, a scientific goldmine and a militarized zone. Its future depends on the ability of the global community to manage its long-term toxicity while navigating the geopolitical instability of the region.